Hello everyone, in this video we will be talking about Leibnitz Theorem and its application. At first let's look at the theorem and then we will go through a solved math on this theorem. So, if u and v are two functions of x, each possessing derivatives up to nth order, then the nth derivative of their product ddx of uv equal to uv1 plus vu1. And we know the formula ncr equal to n factorial divided by r factorial into n minus r factorial. So here's the formula which we have to basically apply, where the suffix of u and v denote the order of differentiations of u and v with respect to x. At first this formula may seem a bit difficult, but actually it's not. First we have to find un and v and then write nc1, then write un minus 1, then v1, then nc2 un minus 2, v2, nc3 un minus 3, v3. We have to write this way as long as we don't get any zero, because if we get 0, that part won't give us any result. And last we have to write u, v, n. Now let's look at our first example, where the given function is y equal to sine of m sine inverse x, and we have to prove this part. For solving this kind of problems, at first we have to differentiate highest subscript of y number of times, and then we have to apply Leibniz formula. Now what is this? What does this mean? Basically, if we look at the y of the given thing which we have to prove, we can see that the subscripts of y are n plus 1 and n plus 2. Here the highest subscript is n plus 2, so we have to differentiate the given function twice. If the highest subscript was n plus 5, then we would have to differentiate the given function 5 times. Now let's first differentiate this part. If we differentiate this part, we get cos m sine inverse x. How? Because dt of x of sine x equal to cos x. And according to our chain rule, if we differentiate this part again, we get m into 1 by root over 1 minus x square, because ddx of sine inverse x equal to root over 1 by root over 1 minus x square. Now we just took this root part in the left hand side, and then we just squared both sides to remove the root. Now we know cos square equal to 1 minus sine square. We have just applied here that, and rest of the part is same, and we can see that we have sine m sine inverse x. This can be replaced by y because it is given in the given question, y equal to sine of m sine inverse x. Now we have finally got this thing, and again we have to differentiate it, as we have to differentiate the given function twice. So let's differentiate it, and if we see here, we can apply the uv formula here. Here we have taken y minus x square as the u and y1 square as the v. First let's keep the u intact. We are basically applying the ddx of u equal u v1 plus vu1 formula here. Now if we differentiate this v part, we get 2v1, and according to chain rule we have to differentiate y1 again, so we got y2. Now we have to keep the v part as it is, then differentiate u to get u1, and we got 0 minus x 0 minus 2x by differentiating q, and we have to differentiate this part again, and we got 0 minus m square into 2y into y1. Here m is the constant, so we got 0, and according to chain rule, if we differentiate y, so we got y1 at last as well. Next we have removed the 0 part, and we have divided both left and right side by 2y1, so we got this part, and then we just took this minus m square y to left part, and hence we have got this part. Now we have to apply the Leibniz formula here. So differentiating n times with the help of Leibniz theorem, we got this. I have colored in different colors so that it becomes easier for you. I have colored the v parts in blue and u parts in red. So at first we have to write u and v, and what is this u and v? Know if we differentiate y, we get y1. If we differentiate y2, we get y2, and if we differentiate y1 n number of times, we get y n plus 1. If we differentiate y2, we get y n plus 2. So similarly, this way we have to find y n plus 2. First we have to keep the v as it is according to this formula, then we have to find un. Our here u is y2 and v is 1 minus x square. So if we differentiate y2 n number of times, we get y n plus 2. Now we have to write nc1. We have to keep doing this nc1 nc2 as long as we don't get any zero term. If we get after differentiating a 0, we will not do. We have done up to nc2. We have not done the nc3 part, because in the nc3 part we have got 0. That's why that part is not written or done. So let's go back to here. Now we have to find u of n minus 1. Here our u is y2, so our u of n minus 1 will be y2 plus n minus 1, which is equal to n plus 1. So here it is, our u n minus 1 part is this red part, y n plus 1, and then we have to differentiate our v1 minus x squared to get v1, so we got 0 minus 2x. Now we have to write nc2, and now we have to find u of n minus 2, and our u of n minus 2 will be yn. Why? Because here our u is 2, so our u of n minus 2 will be 2 plus n minus 2, which is equal to yn. Now we have to differentiate v1, which is minus 2x, to get v2, which is our minus 2. Now we have to apply this Leibniz formula here again in this part, x into y1. So we applied the same formula here. At first we wrote the v part as it is. Here x is the v and y1 is our u. So we have to write un next. Y1 is our u, so our un will be y of n plus 1, and then we wrote nc1, and then we have to find u of n minus 1. Our u is y1, so u of n minus 1 will be 1 plus n minus 1, which is y of n. And then we differentiated v, which is x, and got 1, which is our v1. Then we wrote m2 yn equals 0. Now in the next line we have just put the value of nc1 and nc2. So the value of nc1 is n, and value of nc2 is n into n minus 1 divided by 2. In the next line we have just removed this 0, and we can see that this 2 and this 2 can get cancelled. So minus y1 has been just multiplied in the next line, and in the next line we can see that n has been multiplied to n minus 1, so we got n square minus 1, and in the next line we have multiplied y1 with n square minus 1 and removed the bracket, so we got minus n square y1 plus n y1. Rest of the part is as it is, so I did not explain that. And we can see that plus n y1 and minus n y1 has been cancelled in the next line. Then in the next line we have just arranged it a bit. We can see that minus n2 y1 has gone to this side, and minus x y n plus 1 has been gone to the left, so that we can take common. Our final destination is to prove the given part in the question. That's why we are trying to simplify, so that we can reach the given thing which we have to prove. So after we have rearranged this expression, we can see that from these two expressions x, y, n plus 1 can be taken common. So we took common from these two expression, and from these two expression in the right side we took yn as common. So finally we have reached our destination, and here it is. We have proved that this part is equal to 0. So your next task is to do 2, 3, 4 and let me know the answers. So here is it for now. Thank you.